Okay, so now we're going to talk about elimination. Now, some people will also call this method combination. On the test, you're going to see it's going to be called combination, but don't worry, it's just the same elimination we've already practiced in the book. Now, in order to eliminate both equations need to be in the same form. Now, what I mean by that is if I've got 3x plus y over here and 2, and then in the second equation I've got y is equal to 3x plus a 5. You guys will notice how x is on the left side over here, but it's on the right side over there. That will not work. Alright, you need your constants on the same side. You need the y's to be on the same side, and you need the x's to be on the same side. If these are not on the same side, this is not going to work. Okay, so this is also where solving for y comes in handy, because you're going to guarantee the y is on the left side, x is on the right, and the constant is on the right. So you're going to put them in the same form if you choose to solve for y first. Alright, so here's our first example, solving using elimination. There are two equations. Try it yourself at first and then watch me solve it. Now we're going to subtract one equation from the other. Now this is assuming I've got an equation in the form that you're seeing, that I've already solved for y. This is an assumption I'm going to make things easier and these videos shorter. If I subtract y from both sides, or if I subtract the second equation from the first, y minus y is a 0. 1/3 minus 7/3 is going to be an 8/3, so I have 8/3 x, and negative 3 minus positive 5 is negative 8. Okay, so now that I've done that, I need to solve for x. We can add an 8 to both sides, and I get that. In order to get rid of 8/3, we need to multiply by the reciprocal fraction. So rather than 8/3, I multiply by 3/8. Okay, and that's going to make that 8/3 cancel out, and I'm left with x equals 3. Okay, so now that I know x, I'm going to solve for y. So I'm going to replace an x from one of my original equations with 3. 1/3 times 3 is 1. 1 minus 3 is negative 2. Okay, so here we've successfully used elimination. The reason we call that elimination is because we eliminated the y. Okay, it's much easier to solve if we only have one variable, and that's what we eliminated. Okay, final step, write it as an ordered pair. X was 3, y was negative 2. Alright, so let's look at this next problem. Okay, now in these ones I did not solve for y already. I figured I'll show you guys an example of how this can work even if I haven't solved for y. First thing I need to look for is which variable has a common coefficient. Now if they don't have a common coefficient, you need to multiply an entire equation by some number in order to make that common, in order to create that situation that will work. In this case, well, we've got the same coefficient on y. We've got 1y in both of these. So I can subtract these. Getting tired of talking. You guys are probably getting tired of hearing my voice. So now I've got negative 4/3 x. I need to solve for y. Multiply by the reciprocal fraction. And since that first fraction was negative, I need my second fraction to be negative as well, so that the negatives will also cancel out. So I'm going to multiply both sides by a negative 3/4. And x is equal to 3. Alright, so now I'm going to come over here, I'm going to solve for the y, replace that x with a negative 3. To get rid of y minus 3, I need to add 3 on both sides. Y is equal to 8. Write it as an ordered pair. Okay, now I'll show you, let's go through one more example of how this could work. So let's look at a situation in which perhaps not both of them, we don't have a common coefficient just yet. So let's say I've got 3x plus 2y is equal to 4. Okay, and then over here I've got a 5x plus a 3y is equal to a 10. Now I'm not going to solve this one all the way through. I just want to show you guys what to do in this situation. Now we need a common coefficient for elimination to work. So I'm going to pick a variable that I want to eliminate. In this case, I feel like eliminating x, so I'm going to look at my two coefficients of x. I've got a 3x and a 5x. And I want to figure out what is a common multiple. So if I'm counting by 3s, 3, 6, 9, 12, 15, 18, 21. If I'm counting by 5s, I got 5, 10, 15. Oh, right there. We've got a common multiple. So we're going to multiply both of these equations by some number so that the coefficient on x is going to be 15. Okay, so let's do that. In this top equation, I need some number, 3 times some number to give me 15. Well, I know that that's going to be a 5, so let's change that entire equation by multiplying it by 5. So 3x times 5, 15x, plus 2y times 5, 10y. Okay, is equal to 5 times 4, that's a 20. Alright, so now let's go down to this other equation. 5x times something needs to be equal to 15x. Well, that's times by a 3. And that is going to turn into 15x. Okay, now that 3 times that 3y plus 9y is equal to 10 times 3, which is 30. So now I've got two equations that are going to subtract really nicely. 15x minus 15x, it's a 0. 10y minus 9y, well, that's only 1y. And 20 minus 30 is a negative 10. So we've already found y. Now I just need to substitute that y back into an original equation to find out what x is. Okay, so I'm going to end the video here. I hope that helps you with elimination.